pieces. And they're very, very small, microscopic to the naked eye, and you have to sort of treat the metal with a chemical in order to bring them out. But I have a piece of aluminum here that's been heated to grow the grains and then etched with a chemical etchant so that you can actually see what these grains look like. So all metals actually have this grain structure. I'll get a chance to see this. You can come up a little bit. And so what I'm going to be doing is taking, so in between these grains there are tiny crevices, tiny spaces for, where there's no material. And if you can find a material that wants to penetrate these grains, it will actually weaken the structure, and that's what I'm going to be doing here. So the reason that happens is for something called wetting. Wetting is like an energetic property of materials. So for example, if you put a drop of water on a pane of glass, it likes to bead up, right? That's a very high surface energy. They don't like to be in contact with each other. On the other hand, gallium, liquid gallium, and aluminum really like to be near each other. So gallium is going to find as much surface area of the aluminum as possible to be in contact with. So it's going to penetrate through all these grains, all these grain boundaries, and be in contact with as much aluminum as it can be. And that weakens the structure of the aluminum. So now I'll get going with the demonstration. So I'm going to take a couple drops of this liquid gallium and place it on top of the aluminum soda can. And then I'm going to take a razor blade and score the surface, or scratch the surface. Now the reason I have to do this is because aluminum, when it's exposed to oxygen in the air, forms an oxide, aluminum oxide, Al2O3. It's a very, very thin layer, but it's there nonetheless. And you can't actually see it, but every time you handle aluminum, you're not actually touching the aluminum metal, you're touching a very, very thin layer of aluminum oxide. So I'm scratching through that oxide layer to expose the aluminum underneath to allow this gallium to penetrate into those grains. And I have a piece of aluminum oxide here. So this is a piece of bulk aluminum oxide, but a very, very thin layer of this is actually forming on top of aluminum when it's exposed to air. That happens very, very quickly. So I'm running this sort of like a cooking show. I have stuff that I've prepared earlier through the same methods. But it takes about 15 minutes for this to work, but hopefully this works properly and I gave enough time for the gallium to soak into those grain boundaries, and I should be able to stick a toothpick right to the top of this can like paper. There we are. Third try. And in fact, I can make that hole even bigger and tear the top of this can apart. Just with a toothpick with my hands. So you can see it's almost like aluminum foil at its weakest points. So I can tear that can apart fairly easily. So that is toothpick through a soda can. You guys have any questions? Yeah?
Did you do this with a legitimate buyer in soda?